their corresponding angles are congruent. So the angles that match up are the same. And the lengths of their corresponding sides are proportional. Meaning if you were to set up the corresponding sides as fractions, you'd get the same fraction every time. So last unit we talked about congruent triangles and congruent figures. In this section, this unit, we're going to talk about similar triangles and similar figures. Okay? And again, like we did last unit, a lot of you aced this on your test, we're going to assume in this first example that these two figures are congruent. I know they don't look congruent, we're just going to assume. Hypothetical. These two figures are the same. We want to go through and list the congruent angles, just like what we did last unit. Okay? So if we look here, angle A will be congruent to which unit? Or which angle? G, just like last unit. Angle A and angle G. Same spot, they're congruent. Same order. Angle B will match up with which angle? Angle H. B and H in the same spot, they're going to match up. Angle C is congruent to which angle? I. Same spot, they're going to match up. If you need the diagram, they both have one arc, they're going to match up. And then lastly, angle D would match up with which angle? J. Same spot in the statement. D and J both have two arcs in the diagram, they would match up. Just like we did last unit. Just like what we did with last unit, we're going to assume these figures are congruent. State all the sides that are congruent. So if we look here, AB would be congruent to which side? BH. Okay. BC would be congruent to which side? BC would be congruent to HI. Very good. CD would be congruent to what? IJ. Very good. And then lastly, DA would be congruent to what? AG. Okay? Exactly like what you did last unit, except with a triangle, we're doing a four-sided figure rather than a triangle. We've got a couple more sides in it. Okay? Questions over that? Just like last unit. I did an awesome job on yours. If we look at example 2, you notice we're still dealing with the same figures, but the symbols in between are different. This symbol means what? Equal sign with a squiggle above it. Congruent. This symbol, when you just have the squiggle, that just means similar. So in example 1, we said these two figures were congruent. In this example, we're saying that those two figures are similar. You use the squiggle to say similar. Equal sign with squiggle means congruent. Okay? Well, what did we say if we have similar figures? What did we say about their angles? All their angles were what? Congruent. So exactly like we did with example 1, we're going to do the same thing with example 2. Their angles are going to be the same. You literally are just copying what you did here. A and G are congruent. B and H are congruent. E and I. And then D and J. Because they're similar, their angles are still congruent. That doesn't change. That does not change in similarity and congruence. The angles are always going to be the same in both. Questions over that? Angles still match up. What's different in the sides? What did we say about the sides in which figure you pick first. I like to go left to right, so I'm going to start with the one on the left. I'm going to pick the first side. I'm going to pick AB, just like we did here. I'm going to pick AB. We said which side matched up with AB? GH. Yeah? I'm going to set it up like a fraction. So instead of saying that the two sides are congruent, we set things up like a fraction with the sides. So the sides that match up, you're just going to make them in a fraction. So one side over the matching other. It doesn't matter for the first one which figure you use. You could have said GH over AB. It now matters what you do for the second one. Okay? We said small over big. We have to keep that same pattern. Okay? So the next side we're dealing with is BC. That has to go on the top. Has to go on the top because it's a part of this first figure. Which side did BC match up with? HI. And that's going to be equal, who thinks they know what the next fraction is? So our next side. CD. Which side did CD match up with? IJ. And lastly, what's our last one going to be? EA over JE. So the sides that match up, instead of saying that they're congruent to each other, they're proportional. So one side over its matching side is equal to that other side over its matching side. Okay? If they don't, let's say when you put these, you get 3 over 2. When you simplify that fraction, you're going to get 3 over 2. When you simplify that fraction, you'll get 3 over 2. And when you simplify that fraction, you get 3 over 2. You know they're similar because you get the same fraction every single time after you simplify. If you don't, then you know they're not similar. It's going to be the same every single time in order for them to be similar. If they're not, then the figures aren't similar. Okay? Questions open. Again, if you start with this figure in the first fraction in the top, it has to stay in the top the whole time. You can't flip-flop it or change it. So whatever you start with, you're not wrong. You just have to stay consistent throughout. You don't then.
Why'd you do 4 over 2?
I just made it. So it could have been 4 over 5 or 1 over 2. But I'm just saying the fractions for all three after you simplify down the sides will be the same every single time. If they're not the same, then those figures are not similar. Okay? So if we look here at example 3, we know these triangles are similar, and it's stated the angles that matched up. So it said M is congruent to S, so mark it. I'm going to put one R here and one R there. It said N is congruent to R. So 2 arcs and 2 arcs. And then it said P is congruent to D, so mark that as well. Because again, if the figures are similar, then we know the angles that match up are the same. Then we want to write a similarity statement. Well, writing a similarity statement is the same thing as writing a congruence statement. You just use a different symbol. Okay? So if we want to say that, let's pretend we're saying that these two triangles are congruent. Just pretend. Our first step would name that first triangle any way we want to. Doesn't matter. How do I want to name this first triangle? You're not wrong. Say how do you want to name it? NMP. Right? We have a little bit of space. If we were saying that these triangles were congruent, how do we have to name the second triangle? We went from purple to green to orange. How do we have to name that second triangle? RST. Purple to green to orange. The only difference is, instead of using that congruence symbol, what did we say represents similar? Yeah, just a squiggle. So it's no different than stating that two triangles are congruent. Same exact process, you just use a squiggle. You don't use the congruence symbol. same concept, just different symbol. Write an extended proportion for the ratios of the corresponding sides. It doesn't matter which shape you pick first. I just like going left to right, so I'm going to pick this left one. Give me a side in that triangle, doesn't matter. Any side. And which side matches up with MN if we went from green to purple? SR. Very good. That has to go in the bottom. We used that small triangle first, so what do we have to use again first? The small triangle. You can't change it. Okay? So we use MN. What other side do we want to use? MP. So we went from green to orange. So what side matches up with MP? ST. That has to go on the bottom. And then lastly, again, stay consistent. We have to use that small triangle first. Which side? What's the other side in that triangle we didn't use yet? MP. If we went from purple to orange, what side has to go on the bottom in the other triangle? RT. Okay, done. You could have done this. You could have said SR first and then MN. That's totally fine. But then you have to stay consistent. Then that means the big triangle has to go in the top. You could have said this first. You could have said MP over ST first is equal to this, is equal to that. That doesn't matter. What matters is if you use the small triangle first, the small triangle has to stay in the top. And the big triangle has to stay in the bottom. That's really important. You sometimes get that mixed up. You have to stay consistent. It's generally not wrong with it. How you set up the first one, you just have to stay that same figure for all the rest of it. Okay? Questions over there? Well, about geometry. You're not really wrong. You just have to stay consistent. Another important vocab word is a scale factor. It's just a numeric ratio comparing the lengths of corresponding sides of similar figures. So it's that fraction you get after you put all the sides on top of it. When you simplify them down, it's that simplified fraction. So in example 4, we want to determine if the polygons are similar. If so, write a similarity statement and give the scale factor. Show all your work. So the first thing you need to do, always check, do the matching angles, are they congruent? Do they have the same markings? Okay, so we're good there. Always check your angles first. Okay? Then we have to check the sides. We have to make sure that the corresponding sides are proportional, meaning the corresponding sides simplify down to the same fraction. Okay? So, again, I like to go from left to right, so I'm going to start with the left figure. Give me a side. Doesn't matter. MJ? Okay, we'll start here. 6. Which side corresponds to this side? Going from 1 to 2. WT. So 6 is going to go there. What does that simplify down to? 1. It's really important. Simplify them down to fractions. If you're not getting a whole number, leave it as a fraction, not a decimal. You'll lose points. Okay? And what else I like to do? I dealt with this side. I dealt with this side. I'm going to scratch off just in case I get it mixed up. Give me another side in this figure. JK. So 12. Which side matches up with JK? TU, which is 6. What is 12 over 6 reduced down to? 2 over 1 or just 2? Huh. Can we stop right here? Do we have to do any more work? Why? How? Why are these figures not similar? Why can we stop? these are not similar? Not similar. You didn't get the same fraction. Questions over there? Okay. For B, again, it doesn't matter which triangle you start with. I always just go from left to right for consistency. We checked. Angles have the same markings, so we're going to go to the side. Give me one side in that first triangle. Doesn't matter. Which one? BC, which is 16. Which side matches up with BC if we went from 3 to 1? BF, which is 20. What is 16 over 20 reduced down to? 4 over 5. Okay? I'm going to scratch them out. I used them. I like to do this, so just in case I don't repeat. Give me another side in this first one. Remember, we used it first, so we have to keep using it first. AC, which is 8. Which side matches up with AC? Going from 1 to 2. Yeah. That'd be 10. What is 8 over 10 reduced down to? 4 over 5. Alright, keep going. We have the same thing. That doesn't mean just stop, because the next one might not work. And then how are we going to set up this last fraction? 12 over 15, our last two numbers. What is 12 over 15 reduced down to? 4 over 5. So are these figures similar? Yeah. Okay? We're not done. In the directions it says, determine if the polygons are similar. Done. We know they are. If so, write a similarity statement. Let's do that. Name this first triangle. It does not matter. Name it however you want to name it. ABC. We're saying it's similar, so use the squiggle. If we went from 2 to 3 to 1, how do we have to name that second triangle? DEF. Right? So we did that. We also have to do what? What's the other part of these directions? The scale factor. The scale factor, you already found it. It's this simplified fraction that you got. So our scale factor is what? 4. That's your scale factor. All the sides simplify down to that same fraction, so that's your scale factor. This one doesn't have a scale factor because they're not similar. So if they're not similar, you just say not similar and move on. You don't have to worry about answering anything else. Questions? Last one. Quick one. For example 5, we know that these figures are similar. We use that to help us set up this problem. We want to find x. And in this unit, 90% of the time, this is what you're doing to solve problems. You're setting up a proportion. 90% of the time. There's that small 10% where we'd be setting things equal to each other. 90% of the time, you're setting up a proportion, you're cross-multiplying, and you're solving for x. Okay? Because if we know these figures are similar, then we know their sides are proportional. Okay? So we know that one side over the other is equal to one side over the other. I always start with a triangle that has my missing side. So I'm going to start with this one. That I always put in the top. I always put my x in the top. I always put it first. Then we look which side matches up with x. 7. 7's going to go on the bottom. Questions over that part? I always just start with that. Make sure I have it in there, and it's there. Is equal to, well, what's the only other side in this triangle that has a number? 2. That's the one I have to use. This doesn't give me a measurement. I'm not going to use it. I can't. There's nothing there. I have to use 2. Which side matches up with 2? We just set up our proportion and solve. How would we solve this? So x times 4 is what? And 7 times 2 is? 14. Divide by 4. X equals what? 3.5, or 7 over 2. It didn't specify, so either one's right. That side is 3.5. Yes.
So you also want to do 7 times 2 divided by 4? 7 times 2.
Yeah, that's what we did. We did 7 times 2, and then we divided it by 4.